Bismillahirrahmanirrahim. Today we are going to speak about the Elio factorization of a matrix. Given a matrix, and we need to decompose it into two matrices, upper triangular and lower triangular matrix. For any linear system, it's given that AX or AX equal to B is a linear system. The solution for this linear system can be given by different techniques or different methods. It is given that X equal to A inverse times B, assuming that A is not singular, or A is not singular. For A is not singular, the solution for this linear system is given by X equal to A minus or A inverse times the vector B. We have different types of method to solve the linear system. One of them is to find the inverse. One of them is for using the Elio decomposition of the matrix A. Depending on which method is easier, faster, or sometimes we call it cheaper than the other. Means it is less time consuming or number of operations. For the Elio factorization, define this method. What is the Elio factorization? Let A be an n by n matrix. If A can be written as a product A equal to L U, where L and U are lower and upper triangular matrices. Respectively. Then we say that A equal to L U is an Elio decomposition or Elio factorization of A. Of the given matrix A. So this is the Elio factorization or Elio decomposition. Sometimes we call it the Elio decomposition. Why do we need to decompose A into two matrices? Because sometimes it is faster and less taken or less number of operations that can be done with this one. This is especially if we have very huge size matrices. A is given by, let's say, for example, 100 by 100 or 1000 by 1000, depend on the system that we are looking for or try to solve. Now let's see how to find the LU factorization for some given matrix. Find LU factorization of the given matrix. Number one, say A equal to -1, 2, -7, and 8. To find the LU decomposition for the given matrix, we have two techniques. The first one is called the Doolittle method. We have two methods. So I'm going to use the Doolittle method, and I'm going to explain what I mean by this one. Using Doolittle method. For the Doolittle method, we write the matrix A was given by this number -1 is given by LU. -1, -7, 2, 8 is equal to. For the Doolittle, I will let the main diagonal entries for the lower triangular matrix equal to 1. The main diagonal entries are equal to 1. And let me call this one, it will be L11 or L21. Second row, first column. For the U, I have U11 and U12. 0, U21. Just write the L matrix and U matrix in this form. The main diagonal entries for the lower diagonal are 1, and we need to find now L211, and we need to find the other unknowns. So from this one, we can multiply the two equations and write a system of equations. So I have -1, 2, -7, and 8 is equal to. This is 0 there. Multiply the row by the column. I will have U11 and U12. For the second row, I will have L21, U11 plus 0. And for the last one, it will be L21, U12 plus U21. From the equality of the two matrices, the first element will equal the first entry, second one will equal to the second. So this will give me U11 equal to -1. U12 is equal to 2. L21, U11 equal to -7. But we have U111. So this will give me, multiply this by -1, it will be -1 L11 equal to -7, which means that L11 equal to 7. Now the remaining is to find U21. So for the last one, I have L21 multiplied by U1, 2 plus U2, 1 equal to this one equal to 8. Now we have U2, 1 equal to 7, U1, 2 equal to 2. So this means that U2, 1 equal to 8 minus L2, 1, U1, 2, that will be 8 minus L2, 1 is 7, multiplied by U1, 2 equal to 2. So this is 8 minus 14, which is equal to minus 6. So U2, 1 equal to minus 6. In this case, we can write now the lower matrix, which is given by 1, 1, the main diagonal, L2, 1 equal to 7. U is equal to 1, 1, U1, 1, which is equal to minus 1, 2, 0, and minus 6. To check, let's try to see. L, U, which is equal to 1, 7, 0, 1, multiplied by minus 1, 2, 0, and minus 6 is equal to 1 times 1, 0 times minus 1, 0 will give me minus 1. For the second column, it is 2. 7 times minus 1 is minus 7 plus 0. And last one will be 7 times 2. This one with this is 14 minus 6. I have 14 minus 6. So we will get minus 1, 2, minus 7, and 8. So I can see what is my matrix. Minus 1, 2, minus 7, and 8, which is equal to 8. So in this way, we found the decomposition of the given matrix using the Doolittle method. Doolittle method is just to write the lower triangular matrix with unknown entries and upper triangular matrix with unknown entries, and we construct the matrices to find these unknowns. Another method using the row operation. Using the row operations. We have the matrix which is given by minus 1, 2, minus 7, and 8. This one we will convert it to upper triangular matrix. Convert to upper triangular matrix. Means I need to make this equal to 0. Now to convert to upper triangular matrix or to make this entry equal to 0, we are going to multiply the first row by minus 7 and add it. So let's multiply the minus 7 multiplied by R1 plus R2. This will give me 7 minus 14 minus 7 plus 8. I will have 0 and 6. This will be now the second row. So I will get the matrix minus 1, 2, 0, and minus 6. This is minus 6, minus 6. And you can see this is upper triangular matrix now. So this will be my U, the upper triangular matrix. What about the lower triangular matrix? For the lower triangular matrix, L is equal to, I will take the identity matrix. And let's go back and see what is the multiplier or the multiple there. We use minus 7 as multiplier in this row operation. We use minus 7 to be the multiplier for R1 and we put it in the second row. So we'll go to the entry of the second row in the first column and make it 7. Take the opposite sign. So record the multiplier, that will be minus 7, and take the opposite of the multiplier of that constant. We multiplied by minus 7, take the opposite sign, or multiply by negative, it will be plus 7, and that will be my entry in the lower triangular matrix. So again, by the row operation method, we convert the matrix A into upper triangular matrix. We record the multiplier and take the opposite sign, put it in the lower triangular matrix, and that will be my L matrix. Minus 1, 2, 0, and minus 6. You can see they are the same. 1, 0, 7, 1, minus 1, 2, 0, and minus 6. So you can use the little method or using the row operation method.